Waves. Tsunami, a giant ocean wave that forms after a volcanic eruption, submarine earthquake, or landslide. Waves travel through water near the water's surface while the water itself rises and falls in circular movement.
Wind-generated waves are classified as deep water or shallow water waves. When waves hit the shore at a certain angle, they can create either an undertow or a longshore current.
Deep water waves become shallow water waves when they reach depths of less than half of their wavelength.
Storm surge, a local rise in sea level near the shore that is caused by strong winds from a storm, such as those from a hurricane.
Waves are usually created by the transfer of the wind's energy across the surface of the ocean.
Tsunamis are dangerous waves that can be very destructive to coastal communities.
Waves are made up of two main parts, crest and thrust.
An upward shift in the ocean floor creates an earthquake. The energy released by the earthquake pushes a large volume of water upward, which creates a series of tsunamis.
Swell, one of a group of long ocean waves that have steadily traveled a great distance from their point of generation.
Undertow, a subsurface current that is near shore and pulls objects out to sea.
Longshore current, a water current that travels near and parallel to the shore.
Whitecap, the bubbles in the crest of a breaking wave.
Whitecaps break in the open ocean while swells roll gently in the open ocean.
Fun facts. Seawater is more than 850 times denser than air at sea level, meaning that wave power installation can produce a lot of power with only a small amount of equipment and real estate.
Oceans cover over 70% of the Earth's surface, making them the world's largest solar energy collector. The oceans constitute the largest powerhouse on Earth.
Wave power is relatively predictable compared to sun and wind, which could provide utilities a dependable source for baseload power that is clean and non-polluting.
Wave power can also be deployed close to the shoreline, capturing the energy from breaking waves to power hydraulic pumps or turbines.
Once a wave power station is constructed, the energy is free, which requires no fuel inputs and produces no waste or pollution. Okay, then you want to, for our experiment, which is sand in a bottle, you want to put
Ocean in a bottle.
ocean in a bottle. You want to put sand and rocks in the bottom of a bottle.
Or seashells.
Or you can add seashells or sea toys. And then you want to add some water.
Fill it halfway up. Then add some, mix it up.
Make sure that your sand does not get stuck to the bottom. Then you want to add some mineral oil. Then you want to add some food coloring to turn it blue, like the ocean.
Then put the lid on, and then shake it up.
To make it look like an ocean in the bottom. Then add the rest of the water. Or add some more food coloring if it turns green.
Just go ahead now.
Oops.
Just add the rest of the water. And then shake it up some more. You can either super glue the bottle, the lid to the bottle, it don't matter. And there's your ocean in the bottle.
And that is the sand in the bottom. And as you see how all the sand is layered at the bottom, like the ocean. And if you like shake it up and then lay it back down, all the sand floats back to the bottom.
And it has 3 different layers. Like the mineral oil is like right here on this layer,
Which you can't really see good, but it's there.
And then the food color and water just mixes together. Or whatever.
And the sand it sinks to the bottom because
with the rocks,
because it's the densest.
And you can't really see the rocks,
but they're in there.
Yeah. You turn it on your side, you can see some, and it looks like the sea. So.
Okay. Have you ever seen a surfer ride waves? Did you ever wonder where the waves come from and why there are some big waves while others are small? We all know what ocean waves look like, even if you've never been to the seashore. You've most likely seen waves on TV. But how do waves form and move? Waves are affected by a number of different factors. They can be formed by something as simple as wind or something as violent as an earthquake. Once waves can travel through water slowly and incredibly quickly. Read on to discover.
Okay, and that's our project
on waves.
On waves from Chapter 4, Section 3.